Yes, welcome you all for the live session. And until others join the session, if you have any doubts, you can kindly ask me. Otherwise, we will start with the previous session doubts first. So whatever the contents you have learned in week 7 and how you have done your assignments and practice questions, if you have any doubts on that or any other doubts in the previous session, you can start asking now. So I think only few 10 or 12 members have joined the session. So let me start with the previous class doubts now, if you are not having any doubts. So if you have any doubts, kindly raise your hand or put your question in the chat box. Can you be able to hear me?
Yes, ma'am, you are audible.
Okay. Okay, if there is no question, let me start with the previous session questions first, and I will explain the content of that previous session questions. And we will, side by side, if you have any queries regarding that, you can post it in the chat box, or you can directly unmute yourself and ask the questions then and there. Okay, so first, so the one more question that has been asked in the previous Wednesday session is what is Wsgi, right? So I will, before starting that, let me explain that content with a diagrammatic representation so that you can understand what the API is doing for servicing your programming concept, right? So whatever you are doing using REST API, how the REST API as well as Wsgi API is used to service the request and responses. So I will show a diagrammatic representation. I think from that you can able to understand, right? So now I will start presenting my screen. Is my screen is visible now?
Yes, ma'am.
Just give me 1 minute. Okay, so let me explain what is this API, where it is available in the internet. So let me explain using this particular diagram, right? So we all know that web server is available, right? So web server. So say some web servers already you have studied. Some examples of web server is any volunteers?
Nginx, Apache.
Yes, very good, very good. Nginx, Apache, as well as IIS. So many web servers are available. You can able to, so that are some of the examples of web servers, right? So here I will write some of the examples of right. So some of the, and then whatever the, web server as specified by the student. So that also I have included. So these are some of the web services already, some examples I have given. And here lies your API. So this API can be your WSGI or RESTful API, whatever it may be, right? So WSGI is Web Server Gateway Interface. And this is providing the communication or endpoints between these two web application as well as your web server, right? So web application. So say some examples of web applications. Already you have done so many number of web application examples. Yes. So Flask, right? Flask, Python Flask is used to implement your web application. So similarly, we are having, so these are some of the examples. So why I am writing these examples is to know, to differentiate between, so this is the main thing, web server, and this is the API, and this is your web application, right? So this is WSGI is an example, as well as you can also write a REST API, RESTful API, right? So as well as, so these are some of, and Flask, the Django or Bottle. So many number of web applications are available, right? So you are using this platform to implement your web application, right? So that is what I have represented here as Flask, right? So using Flask, Python Flask only, you are writing your web application, right? So that these are used to, so it is acting as a community. So now you can represent the users, that is user is sending the request, and for that request, he is getting the response. Right, so you can also imagine user is available or client is available here, right? So it will communicate between this and it will send the request back to you, right? So that request will be of so as Narendra sir told in previous video lectures and all, how to implement this RESTful API, right? So that what types of request is and or send, get, post, everything will be sent through this type of request, right? So get or post or put or patch, whatever it may be, right? So that is sent as a request. For that, it will send the response using your web application where you're running your app.py file, which is the Flask file. And similarly, it is this is the web server which is running that web application, and you will be able to see that content in the URL, HTTP URL. Right? So this is how the API comes into picture while you are communicating between your web server and web application. Do you have any questions so far? Otherwise, let me move on. Any questions, or is that clear how API is working?
Yes, ma'am.
Okay, so it may be of WSGI or it may be of RESTful, right? So this is how we are representing this. And I have given examples to understand what type of APIs are available. Similarly, some examples for web application and some examples for web server, right? So this is the first question that already in the Wednesday session, I think Make has asked this question. So I think this question has been resolved now by explaining using. So all the questions related to API and how the API is working, everything can be understood only by using this diagram itself, you can be able to understand. Okay, now, second thing. And this is based on the discourse question, what is schema, right? So in RESTful API, what is schema? Right, so schema. So schema is nothing but it is the metadata that tells us how our data is structured, right? So it is a metadata of data. So what is metadata? Is anyone? Is anyone? What is metadata?
Basically, data, so like information about the data.
Exactly. So it gives some information about the data, how whatever data you are storing. So it will give some information about that particular data. That is known as metadata. That is data about data. So only we are representing as metadata. So for example, so before going to the example, first let me explain this schema fully, right? So this, we know schema is providing a structure to represent the data, and that structure consisting of information about the data, which is known as metadata, right? Structure of, we can include structure of. Right, so right, so that is schema. So it is a metadata that tells us how our data is structured. And then now coming back to our RESTful API, so in this RESTful API, we are using the schema which is known as JSON schema, right? So which is JavaScript object notation, which is used defaultly, it is available in RESTful API. So we are using this JSON schema to represent the data, right? So how the data is represented. So since we are specifying a schema, so it represents the metadata of the data, right? So now if you see the example, you can able to understand, right? So how the JSON is represented. For example, if I am typing name as well as name as Sam, and then course mad1, and then ID, so ID 1 2 3 4. So since these two are string types, I have given in double quotes, and this is a integer type, so I have given like this, right? So this is an example for writing this JSON. So what you infer from here, Sam is a name. So this is the data about the given data. Similarly, mad1, it is the course. Similarly, 1 2 3 4, what is 1 2 3 4? It is the ID, right? So, and this is the structure how you have to write your entire content, right? So this is known as schema. So RESTful API is using JSON schema to represent the structuring of data, right? So JSON schema is nothing but it specifies a schema, metadata about the available data, right? And why we are this JSON, what is the benefits of JSON schema? It is a human readable data format, right? So we are not going to provide, so if you have come across C programming and all, everything we have to populate by ourselves, right? So I am not comparing JSON comparing JSON with C, just for understanding what are the benefits of JSON. So only the data we are representing. So it is a code, easy structuring of code base, right? Everything already inbuilt within this JSON object. Everything is already inbuilt. Only we are providing what is what. So Sam is the name and mad1 is the code. Similar 1 2 3 4 is the ID, right? So what is what we are providing. So since it is a human readable data format, simple person who has learned English but doesn't know anything about the coding part, they can also able to learn what is written here, right? So they can, by seeing this, Sam is the name and mad1 is, so that is how human readable data format that resembles JavaScript object. So it is using this RESTful API as JSON schema, right? So this is how the schema is represented. So schema is nothing but a data, metadata of a data. And the advantages of JSON already I have specified is it is easy to implement the code base, and the remaining whatever the content, how it has to be implemented and how it has to be assigned using this key value pair, everything will be abstracted from the user view. Only the developer should know how to do this. That's it, right? Okay, and we can also represent schema as having of different types. So if you take an example of resource schema, whatever fields that are present for a particular object. So normally JavaScript object notation, it's based on object orientation, right? So we will represent all the contents in the terms of objects. So whatever fields you are using to represent a particular object, that is known as resource schema. That arguments or fields or parameters are required to implement this object, then that particular things are should be provided as resources, right? So that is for example. So there are different schemas that are available based on that content how we are using. Here we have simply used only the key values, right? So either dictionary types or key value pair types, or whatever it may be. So dictionary, it's nothing but it is represented in a key value pair type, right? So similarly, if you are using a list type objects within that JSON, then that type of schema is used, right? So you are defining using arrays or list, whatever it may be, right? So based on the type, the object resources will differ. Right, so resources are nothing but the parameters or attributes or fields that are used to implement this particular object, right? So that's all about schema. Okay, any doubts up to this first 1 and 2? No means we will move on to the third doubt that has been discussed in the previous class. Okay. Okay, let me move on to the next doubt, if you are not having any doubts. So once again, in previous session also, scale up and scale out is the difference between scale up and scale out as well as scale down should be discussed. So that only I am discussing this once again here, right? So scale out. First, we will discuss what is scale out. So scale out means adding more equivalent functionality components in parallel to spread out the load, right? So for example, if you are having two web server instances, right? So instances means already in the previous class, I have explained that it are created virtually. That means two instances can be from one physical resource or two instances from three physical resources combined into two resources. Both are possible. More physical resources into one virtual resource is also possible. Similarly, similarly, one physical resource into multiple instances is also possible based on the requirement of the client, right, or the user, right? If the user is an individual user, within one physical available resource itself, you can use hundreds, thousands, or 10,000 number of users can utilize one physical resource into number of instances, right? If it is for a particular organization, then more number of physical resources should be combined into one virtual instance, right? So scale out means we are having more number of web server instances. So this is first instance, second instance. So if these two instances are combined to run your web application, right, and there are more number of requests that are getting accumulated day by day, and you're not able to handle all the requests for that particular web application, then what it will do, you can automatically enhance it by adding one more resource, that is instance, to this particular available resources, right? So that is known as scale out. So elasticity will be automatically, it will provide the elasticity based on that. And you will have elasticity will be provided, right? So this three will be added. So this is known as scale out. So equivalent component, right? For example, if this particular instance is having a particular, how to specify, 2 GB of RAM as well as it is of i7 processor, as well as it is having 1 terabyte of storage, right? So same thing, 2 i7, 1 terabyte, right? So same equivalent instance is added to this environment to provide the service as it is, to enhance its, to handle the number of requests if the request is increased. Similarly, if the request is keep on decreasing and you are serving only 3 or 4 requests per day, automatically this will also be eliminated from the available instance. That means only one instance is enough to serve your request, right? So that is known as scale down. And scale down is nothing but removing the resources from the existing cluster is known as scale down, right? So that is known as scale out and scale down. And the difference in scale out and scale up. So scale up already I have specified. For example, if you are running in a supercomputers or mainframe like computers, right? So mainframe computers and all, yeah, there will be extension slots that are available to increase your memory capacity, as well as you can also add processor and increase the processor speed also, that also available, as well as you can also add external hard disk or any other hard disk to the available system itself, right? So that is known as scale up, right? So you can enhance the available system by increasing the memory capacity, processor speed, as well as the disk space, right? So that is known as scale up. This is done for a same system, but here in scale out, we are adding more number of instances which are equivalent in capability to provide services to the customers, right? I think I think some questions are there in the chat box.
Excuse me, ma'am.
Yes.
I didn't get the distinction between a scale out and a scale up.
Can you able to hear me? Yeah.
Now you are audible.
Okay. Did you understand what a scale out is?
Yes, ma'am.
Okay, we are adding virtualized instances when there is a more need of requesters, right? Similarly, we are removing when there is no. So scale down is common for these two. But what is scale up is, so already in previous classes, I have specified, we are using this mainframe like computers or supercomputers. So these computers are provided as a if you want to enhance this mainframe like computers, right? So within the, so only one computer is available in the organization, but whatever the request and request are handled by this particular mainframe like computers, if it is not able to handle with the available memory, you can extend the memory by inserting the memory. There will be extension slot, right? Memory slot. You can increase the memory by inserting the memory slot, inserting the memory card for that available slot. Similarly, you can also configure processors. For example, if it is using 2 CPUs, you can also include 1 more CPUs to this, but it is a single system. It is not. So here, if you see, you are getting more number of instances of same capability, but here, whatever is already existing will also be there. You will insert more memory into the available system. Similarly, you will enhance the speed of the processor, as well as you can also use external hard disk to enhance the storage capacity of the already existing system, but it is the already existing system. Only you are, so for example, if you take, you can take your laptop or desktop computer at your home. If you want to enhance the memory capability, or if you want to enhance the hard disk capacity. What you will do, there will be a memory slot, that extension slots are available. You can buy a RAM and then you can insert it into your laptop. That is known as scale-up. Existing system enhanced with the available slots by providing the corresponding devices to the available slots. Clear?
Yes, ma'am. But what do we mean by adding instances? Is that mean adding some more computers?
That is what I have specified. It is as virtualized, but this is a physical one, right? So for banking and all, you can take for banking, ATM machines controlling and all. There will be a system which is similar to mainframe systems or supercomputer systems. So they will take care of the entire ATM node, right? So you cannot connect ATM directly to the internet, right? So it will be connected to the banking system. From the banking system, it can be able to connect it to the internet. But by connecting to the banking system, they will have this type of infrastructure to maintain. It is a physical system. Virtualized means that is what I have specified. One physical. So in cloud environment, there will be a data center where they will have racks and racks of spaces that are available, and that spaces are used to provide different virtual instances of requirement based on the user need, right? So what if you are getting a web server from a cloud environment, which is a virtualized one, and that instance you are using to implement your web application, and if your web application the requests are getting more, you can add up the same instances of equivalent capability to the available web server. So automatically what it will do, for example, this will take care of 100 requests, next one will take care of the next 100 requests, right? So that instances meaning that it is virtualized one. You cannot predict this particular instance is stored in the particular rack one of this data center, like that you cannot predict. But here you can visualize that it is an available mainframe machine that is available in a particular organization in a particular location. And if you want to enhance it, you can add a memory into the memory slots. Yes, got it?
Ma'am, to buy cloud-based server, where will I have to approach?
Either Amazon or Google. Amazon cloud services are available. So based on the type of service you need, whether you need only storage, Amazon S3 is available. And if you need the virtual machine similar to that, Amazon EC2, Elastic Cloud Computing, right? So since 2C is coming cloud computing, it is represented as Amazon EC2. Amazon S3 or Amazon. So like that, so many, but you have to pay for it. They will ask the credit card numbers and all. You have to pay for it. And if you want to implement the same thing in your systems also, it is available. You have to implement the cloud setup itself in your system to provide instances to implement the content, right? So that is also you can do it by yourself. But for now, for your understanding, your laptop is enough to implement your web application, and you can run the application and see the outputs from your laptop itself. So this is for production type environment. But what we are working now, it's a development environment, right?
Okay.
Okay. So that is known as scale out and scale up. Right. So these are the two questions I want to insist on based on the previous session queries.
Can I ask a question?
Yeah. Yes.
In practice assignment, can you discuss all the numericals there?
All the
numericals. There are numericals on this.
Okay, Sonal, did you get the question? All what she is asking? All the medicals.
All the practice questions, ma'am.
Okay,
No,
okay.
not all practice. I mean like numerical.
Numericals that are in practice.
Okay. Just give me 1 minute so that I will load the practice session questions into my system. Just I will open it, right? So just give me. Can you specify what is the number of that question? Question number in practice assignment?
I think first question is 1.
Question number 1. Okay. Make, I think I have explained this question in the previous class also.
I missed this question. Like second question isn't it's numerical and 8th, 9th.
Magnetic disk operating at. Second question.
Yes, ma'am. And like I want to know what is a bus width?
What is the?
Bus width, like in first question.
Okay. So normally that bus is nothing but if you have seen the chip motherboard and all, you can able to understand. So just I will show you. Just give me 1 minute. Right. If you have seen come across the motherboard which is in your CPU, it will consist of CMOS battery as well as your RAM slots and all, right? So there will be a silver color line joining all the contents in your motherboard, right? So green color chip will be there. Within that black color content will be placed in that motherboard, and it will having different types of slots and all. And some slots there will be a parallel line, parallel cable that is connecting to that, right? So let me that is represented as bus, right? So bus is nothing but it is used to connect between the devices, right? CMOS battery will be there, RAM chip will be there, RAM slots will be there. So many number of things will be there. There is a communication link between these two, all the links whichever is available, and that so whatever black color chips are available, that will be embedded on that green color motherboard, right? So using that, you can able to communicate using this bus type. So bus is nothing but, so for example, if you are having RAM here, to connecting to the CPU, the connection is used here is bus. Similarly to the input output devices, whatever the input output devices that are available, that can be also connected using, so this is also a bus. Input or output devices. Right? So that bus width is given here. So now let me explain the question now. So a magnetic disk operating at 7,200 RPM rotations per minute is being used to store data. This can only spin in one direction at a constant speed of 7,200 revolutions per minute. So if the operating system sends a request to the disk controller to fetch data from the disk, so how the disk will be organized? So here if you see the disk similar to your idli cooker, right? So we all will have idli cooker in our homes, right? So there will be a spindle in between, and then we will have this hard disk which is arranged like a plates in that spindle, right? So that is the disk how it is available, and using that we are representing the disk operating speed. That means it is rotating. How many rotations per minute it can do? So 7,200 rotations, right? So it is rotating. All the disk will be rotated in one direction, right? So it is rotating. So that rotation is represented as 7,200 RPM. And the disk can only spin in one direction. So that is already I have told, it can rotate in only one direction. And that constant speed is also 7,200 revolutions per minute. So storing the data is also, it is taking 7,200 rotations per minute, as well as it is the spinning constant speed is also 7,200 revolutions per minute. So if the operating system sends a request to the disk controller to fetch data from the disk, what is the worst case latency before it can start retrieving the data, right? So here per minute, they have given us 7,200. That is the constant speed. So since they have given us per minute, we are representing that as 60 seconds divided by 7,200 RPM, right? So that is represented in milliseconds as 8.33, right? So that I will represent here. So if you convert the 60 seconds into milliseconds, so what is the value of seconds into millisecond? So I don't know where my screen has stuck here. Just a minute. Okay, now it's I can able to do one, right? So 60 seconds divided by 7,200 rotations per minute, right? So here we are converting this into milliseconds. So the milliseconds is 60 into 1,000. So 60,000 divided by 7,200. Right. So if you divide this, I think you will get the answer. Okay, got it? Make?
Yes, ma'am.
Okay.
So
since they have given per minute using that, but the data storage, so that is the one more point they have given us saying 7,200 is to just to twist twist the question. But both are same, so no need to confuse about it. So the rotation speed is also same. The storage time is also, they have given us 7,200 rotations per minute. So that means so you have to take one 7,200 RPM, and then since it is for per minute, you have to time by speed, right? So that is what they have given here. So what time by speed, you can represent that, and what value you are getting, you can mark that value in that, right? Okay, what is your question? You started to ask something.
No, ma'am, nothing.
Okay, second question on 8th and 9th, right?
Yes, ma'am.
Okay.
And ma'am, can you explain fourth, like, as well?
Both question, 8th, 4th question. 4.
8, 9.
Okay, 4. So your application is such that most of the time you need to look up a database entry given in the first name of a person. Which of the following indexes will be helpful?
Ma'am, I'm having like problem with index questions. Like, I don't know how they work here. Like, I have a basic idea, but
so index is nothing. So here, if you see, if you are representing some data in the database, obviously it will be indexed, right? So just I will show you what is index representation. Okay. So for example, if you are storing the content in this format, right? So whatever content that will be stored in a memory location will be in a, either it will be in random location or in the contiguous memory location, right? So normally the memory locations will be represented in hexadecimal notation. So here I'm just writing some values 0x011 something here. And then it is pointing to some value. So this is the memory location. So let me write the memory location here. And this is the value. So based on the, what is the size of your word, right? So normally the memories are arranged in the word size, right? So if it is of 32-bit or 64-bit computers, based on that, the word size is determined, right? So normally if you are downloading some softwares also, it will ask what type of operating system you are using, either 32-bit or 64-bit, right? So that specifies the word size of your computer architecture. So that word size, so either it can be of 32 bits, so that means 4 bytes to represent the memory, or it can be of 8 bytes, right? So if it is starting with 0, next will be 0x00 32 00. So that is how it will be represented, right? So indexing is nothing but how we are representing the word. So that means here there will be 4 slots of location to represent the content, right? 4 bytes is used to represent the content, and next 4 bytes for next based on the operating system, whatever you are using, right? So for example, if you are storing some value here, it will be stored in this 4 bytes, right? So if you are not having any other values here, it will be stored in the least significant bit. For example, if I am storing 10 here, it will be represented as 0010, right? So that is how we are representing that values here. So indexing is nothing but
one question.
Yeah.
I didn't get like 0010. Like, is it memory location?
No, this is the value. This is the memory location. You can represent, let me give another value. So just actually I have to represent this particular value in 8 bits. Is that right? Because it is of 32 bits.
So we're converting ASCII into like a binary. What do you mean?
So normally in computer can understand ones and zeros, right?
Yes, ma'am. So that's why we're converting all the letters A, B, and C to binary digits, right?
Yeah, while it is storing in the memory, even though if it is a program, so whatever you are writing in a Python code Python code to be executed, that should be also converted into a machine language. Then only the computer can interpret your program in ones and zeros. So while you are executing the program has to be brought to your memory location, right? What normally if you have saved the program will be available in the hard disk. While you're running the program will be loaded in the memory location of the RAM, and from there only it will start executing. So while loading, automatically the program will be loaded in the values of ones and zeros only.
And I'm like, for memory location, like 0 times, like how is it represented? Like
which one? This one?
on left you wrote these values. Like,
this is what I have specified, right? So you can represent the memory location in hexadecimal also, right? So if 32 bits are used, here I have given the address location. So for indexing, you have asked me, right? So for to place some pointers over indexing, I have represented the memory location itself as an indexing parameter, right? So this will point to the first memory location of your memory. And then since it is of 32-bit processor, the word representation in your computer architecture, so next representation will be starting at 32. 0 to 31 will be the first word, and 32 to next 63 will be the second, and here it will start from 64. Like that it goes off, right? So if you want to retrieve the content automatically, I have already told you, right? So magnetic disk consisting of, so how it will be arranged, if you see, this is the top view of the disk. If you see the disk, it will be arranged in sectors and tracks, right? And the data will be stored in this tracks, right? So all the tracks. And how it will be arranged? It will be arranged in this memory type representation. So using the memory location only, so for example, if you type A is equal to 10, right? So what is the value of 10 in binary? It is 1010. So if you are storing here is 1, 2, 3, 4, 1010. So this is the last significant byte of this value. Now A will be, for example, A is pointing to the memory location 0x000, right? So this is the memory location of A. So that is how, if you print the value of A, you can able to see the value is 10, and in which memory location it's available, you can use that type def to represent what type of so type def is used to identify the data type. So that will not show here. If you know that C programming and all, if you use ampersand symbol, it will display the memory location of A, right? So this is the index. A is referring to this particular location where 10 value is stored. So A is equal to 10, already you know, in Python also you can write as A is equal to 10, right? So what it is actually doing in a computer organization, 10 is stored in a particular memory location. That memory location is represented by this variable A. And how it is arranged? It is arranged in a tracks and sectors in a magnetic disk. Clear, mate?
Like this variable is randomly assigned, or like is it like
Yes, actually here, for example, only I have told you, but it will never start in the same. It will not arranged in a contiguous memory location. It will random, so there will be a pointer. So if you have seen the previous days gramophones and all, so how they will use to hear the music, there will be a disc which is in black color, and there will be a hearing you have to place this in any one portion of the disc, right? So automatically the song will keep on singing. Same concept here, there will be a pointer. That pointer will keep on rotating in the disk, and randomly it will store the content in any location where the memory is free, right? If I have given this value in this particular word, automatically it cannot able to store any value in this particular memory location. It can store any values in this location. Whichever is empty, it can able to store. So that is why we are representing as random access memory. That means it is able to store the content randomly as well as retrieve the content randomly. So here, for your reference, for indexing, I have represented it is the starting memory location where A has been stored. But in reality, it will not store in a contiguous manner. It will be stored in a random manner. And once it has been stored in a random manner, and indexing will be used to refer. So to go to this particular location, there will be an indexing table that is represented as file allocation table or a network trivial file allocation table. Like that, we will represent
a hash table.
Yes.
It's not called a hash table here.
Yeah, you can call it as the hash table is nothing but we are using a technique that is known as hashing, right? So for example, if you are using a hash function, 25 mod 10. So mod 10 is the hash function I am using for storing this value 25. Then what it will do, 25 divided by 10, the remainder will be 5. So it will be stored in this file location in the memory. So that is known as file allocation table also you can represent using hashing technique. Then it is represented as hash table, right? So if you are having 10 locations, automatically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So since it is 5, 25 will be stored in this particular location based on our hashing function. And if you want to store 32 divided by 10, it will give 2 as value. So 32 will be stored in this location.
But this is
Excuse me, ma'am.
Right? Yes.
What if all the locations have already been filled?
So that if all the locations has been filled, it has to go for the next sector. So that only we are having sectors representation, tracks representation. Then we are having another disk if this particular disk is filled. Right. So that also that is rehashing also you can do. As well, so many number of data structure techniques are available, right? Open hashing, closed hashing, linear in open hashing, linear probing. So many number of techniques are available. So what I have specified here is linear probing. So just it will apply the hashing function, and once it has been hashed, what is the remainder? For example, if you are representing linear probing, if 35 comes, here 32 is stored in second location, 25 is stored in fifth location. If 35 comes, what it will do, 35, that is also resulted in 5. So what it will do, after 25, it will create a single linked list and 35 will be stored here. So that and all big ocean of representation in data structure, right? So just you know what is hashing. Hashing is nothing but it is a technique that is used to arrange the data in the available memory location in a particular format. then only by using the indexing concept, you can retrieve the data easily from the memory location. For that only we are using that, right? So you just know what, yes, tell me.
But here we are not using hashing, right? We're using fat here, which is different than hash, right?
See, file allocation, so there are different techniques. Don't get confused. If you are going for a particular particular allocation thing, it can now have any technique, but the concept is it has to retrieve the content using the indexing information, right? So that is the concept beyond all the techniques. How they are retrieving, that is the technique decides, right? So maybe fat can be also represented using hashing. Maybe it can also use any other techniques that we don't have anything to do with that, but it is used to allocate the content in the table for the given memory location. So that is the purpose of using that allocation table, right? So don't get confused between all the topics. If you want to learn all the topics, because whatever I am teaching now is nowhere related to what we are studying. With that tracks and sector itself, you can able to understand. If I am going in depth in hashing data structures and all, again you will get confused why we are going for this. So fat allocation table is nothing but you are storing the content in that memory location and you are putting an index pointer over it. Using that index, you are retrieving the data. So for index representation, I have given a representation for memory here. That's it. You don't need to compare with the memory location also. You just say stick on to this array representation of index. Using that, we can able to retrieve the content. Okay.
Yes, ma'am. And like, then what does first name, last name concept comes like?
What concept?
Like there were questions like, should we index on first name or like second name if we want?
So that question is for now. You know what is indexing, right?
Yes, ma'am.
Okay. Now we will go back to the question. So what is the question there? Your application is such that most of the time you need to look up a database entry given the first name of the person. So in the question itself, they have given that using the first name of the person only, most of the time you are searching the database. So which of the following indexes will be helpful? Which type of index, if you use, it will be helpful for you, right? So the index which starts with first name should be used for retrieving the content. So whatever the options that are available here, first option is index on roll number. No, because we are keep on frequently searching based on first name. So first option is not applicable. Second option, index on first name. Okay, you can take this because using that index on first name, you can easily retrieve the content from the database. And third, tell me.
Name repeats then, because name is not unique, first name.
First name is not unique. If there are two more numbers, based on that two more numbers, for example, if there is two values, let me take my name itself. There is two Devis or three, more than three Devis are available. First, it will retrieve Devi, which is having the first registered roll number. Because we are searching through index only, right? So let me show it in this screen. Suddenly the screen is not appearing for me. Right? So 0, there may be any number. So let me start with the A. And then for one index, so for example, I'm writing, right? So 4 is also varying. First, it will retrieve this one because it is having the, by indexing, we are searching, right? So first they will come first and next will come second. So what is confusion here for you? No, there is no confusion because it has been arranged in an indexing manner. And if it is not indexing, you can use your roll number to make it as indexing manner. Then you can retrieve the content, right? But already it has been indexed. So there is no confusion if there is no more than one value in the same name.
Because now if we wanted the fourth one instead of the third one, it will give us the
But that question is not like that, right? So the question is, using the first name, most of the queries that are sent to the database is based on the first name only. So then what type of index you will use to do it fastly? So that is the question. If they have asked if you want to retrieve more than one name which is of same values, then only you have to think about it. Why you are thinking about it? You just narrow down your scope and be specific towards the question. What question they have asked, for that only I can explain, right? So this is how they have asked the question and this is how you have to index it, right?
Yes, ma'am.
Okay. Okay.
But in real life situation, like what would someone do? Like they would not index on first name only, right?
Then you have to combine your roll number along with your first name. Then only it can work, right? Based on your question.
Yes, ma'am.
Okay. Because roll number will be unique for all the students. So you cannot merge the roll number with the roll number cannot be same for all the students who are having same names. So using that roll number, you can distinguish. Okay. So second option is correct, as well as the fourth option is also correct. I think so. Because first name is occurring first, so that we have to give importance to the first name only. So first name occurs first. Okay. So shall we move on to the next question, 8th question?
Yes, ma'am.
Okay. Which of the following is better suited for sorting connection information in a social network? RDBMS, social network itself, if you have gone through the lectures of Nitin sir, he has given pointers towards this graph database. And that graph database is mainly used for social networks. So how I will show it in this diagram, what he has explained. Once again, I will share it here. Okay. For example, if there is a friend who is named as X, right, and he is joined with the so Facebook is a social network. You can take Facebook. Y and Z is the friend list of X, right? So if you are having another friend of S who is not known by Z and Y, no need to do anything with this Z. And friends of friends. Facebook is a concept of friends, right? So you can also get friendship of this Y who's there, right? So the graph-based representation is the best example. So that is also coming under NoSQL concept, right? So here Y1, Y2. Right. So since Y is friend of X, he will get the suggestion that Y1 and Y2 is friend of Y. So if you know, you can send a friend request to him, right? So, but even though X is friend for Y and he is getting suggestion, if he doesn't know about X, he can accept it. And if he accept, once again, there will be a link between S and Y through X, right? So already this link will be used for connecting between X, S and Y.
MongoDB can be used, right, for this?
MongoDB, once again, let me check that lecture concept. I think MongoDB, they have explained in the, so I have just made a note of it. graph-based examples or
Sorry.
Amazon, Neptune, and Neo4j. These are some of the example databases. Just I will write it here. So this is the example.
We cannot use MongoDB for
That MongoDB is specifically given here for
document.
Document based. Yes, correct. Exactly. MongoDB is for document database, and for a key value, Redis and column store, you can use HBase or Cassandra. And graph based, it is Amazon, Neptune, and Neo4j. And time series database, you can use RRD tool, InfluxDB.
Yes, ma'am. Like I have question on key value and time, like time-based data.
Yeah, tell me what is your question.
I didn't find anything like relevant.
Key value. Did you understand about JSON?
Yes, ma'am.
Same thing is followed in key value. JSON is a key value. Best example for key value is JSON. Right? So how you are writing that? You are writing, putting two curly braces. Within that, you are giving some, that is metadata for the given data, right? So if it is name, you are giving that name. Same thing I have explained, right? So this is a key value. This is the key and this is the value of the key. So dictionary type represent whichever data types that are coming like dictionary type representation, they are represented as key value pairs. Okay. And one more, what is the one more doubt you have? Time series.
Yes, ma'am.
Okay. Okay, time series is not used for normal databases. It is for analytics purpose. Maybe for research purpose, they can use this. Only for analysis purpose, we are using this time series. That is, you can audit the log records. Log records. So what is log records? Whoever is accessing the web application, and how much time they are so that is why whenever you are going for a particular website, it asking you to accept the cookies, right? So that means if you have accepted the cookies, how many times you are coming across that website, and what is your login time and what is your exit time, everything will be taken care. They will take us a survey for their website analysis, right? So that is done by this time series database, right? So it will audit the log records based on how many number of users are using that particular web application, right?
Like in this, like data is not stored in histograms or anything, like in showing time, like.
No, everything will be stored. For example, from which IP the request is coming. For IP or domain name, whatever it may be, right? So IP or domain name, from which IP it is the request is coming, and what is the login time and what is the logout time, what are the links they are surfing within that websites, what are the links they are surfing, everything will be stored. Without some data structure, they cannot store all this information, right?
But like, is it like in a tabular format, like RDB?
Sure. Like it won't be similar to RDBMS, because RDBMS, it's like a matrix format. For example, if there is a 3 column and there are 3 rows, automatically it is a 3x3 table format. Even though you don't have any values, null value will be represented. But here, based on how the RDD tool is used or Influx database is used, based on that, they will store all the login information. So whatever database representation, that will be in some format.
NoSQL, like.
Some format. That is what I have specified here. Name, and then course, if you represent course, as well as if you have ID. Right, and then if you have some other for particular student, you will have this information. But for this is for day scholar student. If you consider for hostel student, day scholar student don't need that hostel information, but hostel student requires. So for that, name will be there, and then course will be there, ID will be there, and one more column, hostel aid, that will also be there. But if you see here, only 3 attributes for this particular representation, but for hostelers, it is having 4 values to be represented in the key value pair, right? So that is possible only in NoSQL, which is not possible in SQL. Arrangement of data based on the need, not for similar to tabular column format or CSV file or Excel file, whatever it may be, how it stores all the content.
So
Right.
key value and time series are stored in NoSQL, and they're stored in the same way, but only difference is that in time series we have more columns related to login time, exit time.
Exactly. We related to login details, there will be also mostly it is used for analytical purpose. Right. So if you want to study about your, so if you want to, when will be your website load will be high, when your web application load will be low, and when your applications will, how many viewers are viewing. So if you take YouTube and all, if you send a video, how many viewers will be there, right? Like that, you can analyze how many views, how many hits over that particular, everything can be analytical representation of a particular website can be analyzed using this time series database. Okay.
Yes, ma'am.
Okay. Anything else? Let's start with the 8th question now, right? So graph based is for social networks. Because best example, you can take Facebook. Friends of friends can be possible only graph based database. So they are good capturing connections between people in social networks. And LinkedIn or Twitter, everything, right? So if you are making one friend, automatically the friends of friends will also be suggested for you. You have 14 connections for him, 14 connections are similar for you and him, so you can make him as a friend. Like that, there will be so much of recommendations, so that we are representing as graph database. 9th question. You have a data center where each server has 1 gigabit. So for this, I think sir has represented clearly. Abhishek sir has given the content in discourse. I think Sonal, right? I think he has represented 2 times.
Yeah. This question has been solved on the discourse.
Yeah. And he has given clear explanation for this. Let me also say that same concept that has been used here. So what is the question? 1 gigabit per second network connection, but the overall data center has 10 gigabit per second connection, right? So each server, so data center, already I have told you, one data center can populate more number of instances of web servers. So for each server, the populated web server connection is 1 gigabit per second. And the data center itself, it can support 10 gigabit per second connection. So if your app becomes more popular, you start getting 10,000 requests per second. At each request needs 50 kilobytes response, right? So 10,000 requests per second and 50 kilobyte per request. So 10,000 requests means 50 kilobyte means 50,000 into 10,000, and it will represent that content into, and we are converting into bits, and that is also represented. Right. So based on that, what we have to do, the total response bandwidth is more than the handled by single server, because single server can handle 1 gigabit per second. But how much requests are getting? 10,000 requests per second. So you have to scale out to multiple servers. Already, I think whether you have joined the session earlier, because scale up and scale out also have given pointers towards that 2 points. And then scale out is used because we have to populate more instances of servers to handle all the requests. Okay. So option 2 is correct.
Yes, ma'am.
Okay.
And ma'am, I have one question regarding API. Can I ask? Like, I know it's week 6, but
Okay. API also, if you have joined this, what is the time you have joined? If you.
No, I know what API is. Like, this one basic question.
Okay. Yeah. Tell me.
I have a doubt regarding API schema.
API schema also I have given. So only for you I have solved all the doubts in the starting of the session.
Yes.
Okay. But I think you have joined late, right? Schema also I have given pointers towards schema. Okay, no problem. Schema is nothing but that is what I have represented in JSON. A RESTful API is using this JSON schema. So schema is nothing but it's a metadata for a data. So in the previous slide, there is my So I have represented this JSON file, right? So schema means if you see this particular value, can you able to understand what it is? Key value pair.
Yes.
Whatever value you are giving, it is a name, right? So name is the metadata for the given data. So this structure, metadata structure that is provided to the data, then that is known as schema, right? So we are providing a metadata structure to the given. So that schema will represent how to represent the data in your language, right? How to represent the data. That is, information about the data is represented as metadata, and the structure of the metadata is represented as schema.
So schema is like stored as JSON.
No, JSON is an example of schema. SQL have its own schema. This JSON have its own schema. Like that, each and every language, what you are studying and how the data is given as input to that particular languages, it is using a structure, right? So here, if you see, this is the structure. This is the structure. So you are using a curly braces. Within the curly braces, you are specifying the values in a key value pair, right? So this structure is used to give the data. So that structuring information, that is metadata, structuring information of metadata of the data is known as schema. That may be for JSON or maybe for SQL or maybe for any other language, whatever you have learned, right? So how you are giving the data in a structured form, that is known as schema. Right. So already I think I have given the content about
API schema, like many, like their date, ID, link modified, last modified, password, and then author. These are all parts of API schema, right?
Yeah. So that is what here, if you see, it is a simple representation of the structure. And if the structure includes any functions, or if similar to what you have asked, if it is a date type structure, it should consist of what is the day, what is the month, and what is the date of that, right? So that is known as date type structure. Date type schema. As well as if it is a title type schema, what is the name of the title and where it has to occur, and what is the X and Y axis to be represented. So some of the fields that are supporting that schema, whether you can view it or you can edit it, or so context based on that title, whatever the context that can be done based on this resource title that is represented as schema.
Yes, ma'am.
Okay, any other questions from the students? I think from Sonal, is there any question in chat box?
No, ma'am.
Okay, now I think now we can start with Menti, if there is no other questions. If there are any other questions related to today's session or previous session. Yes, Sonal, can you please present the Menti?
Okay, ma'am. I'll share.
Thank you, thank you. Yes, kindly note down the, kindly go to www.menti.com. And the code for menti.com is 93079891. So kindly join this, and meanwhile, if you have any doubts, kindly post it in the chat box. 10 members have joined. Meanwhile, if you have any doubts, you can kindly post it in the chat box. Yes, there are 49 students in the Zoom meeting, but only 20% or 10% students are participating. So I think it will be more interesting if more students are participating and entering their solutions for the questions. At least you can participate through Menti, right? Yes. 14 students so far.
Yeah, okay. I think we can start, ma'am. 15
Yes,
minutes.
yes, we can start. We can start.
Okay, anyways, if anyone want to join in between also, so just go to this menti.com and enter the code, and you can answer it in between also. Yeah, so I think I can start off by the question. Yeah, so this is our first question. The question says that what are the different memory hierarchy present in your computer? Very basic question, but if we talk about week 7, we are basically talking about the memory, right? So this is the first level of thinking in that way, that how many types of memory are in your computer and what are their levels, and you can say that at hierarchy. So yeah, So we are waiting for your response, and then after we can start discussing upon. Yeah, okay. My screen is visible, right? The question is visible to you? Well,
Yes, Sonal. Yes, Sonal.
okay.
Visible.
Okay, let me hide.
Just
that.
hide it. Okay.
Yeah. Yeah, I can see 4 or 5 responses. So please post a response as soon as possible, as you can see that we have less time with us. So it will be good that we'll be discuss more and more concept in that. So here we are talking about memory hierarchy, right? So don't be confused into that memory components and memory hierarchy. Yeah, okay. So I think we can start with discussing the question. Let me see what you guys have responded. Okay. Okay, so registers and then SRAM, DRAM, SSD, and then HDD. Okay. Register cache, DRAM, SSD, STD, HDD. Okay. Okay, 5 memory hierarchy. What is? I don't get it. Register, cache, DRAM, STD, HDD option. Okay. Yeah, so as far as the response is concerned, I think all of you are good at your position. The answer is right in somewhere. So yeah, let me explain to those of the student who are really confused in this concept. Yeah, this is very basic concept as far as this week is concerned. But some of the student, I think they are confused. So anyways, let me explain it. Let me stop sharing and then I can open that paint. Stop sharing first. Okay, so this is my paint screen. My screen is visible, right, ma'am? Hello.
Yes, ma'am, it's visible.
Yes, Sonal. It's visible.
Okay. Yeah. Okay. So yeah, this explanation are for those who are just confused in these things, that how many types of memory we had in our computer and what are their hierarchies. So see, first of all, we just have to remember what is the architecture, right? If we talk about the architecture, architecture of what computer, right? Of our computer. So here we have some input unit, and then we have a processor, right? We have a CPU. We have a CPU, and after that we have a output unit as well. Okay. So in CPU, you know that what are the components of CPU, right? We have a control unit in this, and after that we have a ALU in that, right? So apart from that, we have one more thing, right? So what was that? That is the memory unit. Okay. So yeah. So these are the things. Let me. Okay. So yeah, see, what the input unit do? Input unit basically takes the input data, from the external user, or you can say that, yeah, you can say that external user, and gives the data to the CPU. Okay. Within the CPU, either values will be given to ALU or the values will be given to CU. So apart from the CU and LU, the values basically will be given to the ALU. Okay. So ALU is basically responsible for the all the calculation kind of thing. So what the CU does in that, the CU is the important part of CPU. And what it does, it controls and monitors all the activities within the CPU, all the calculation and all the things that ALU is doing inside the CPU, how it is managing the data, how it is calculating the data. All these things are manages and monitored by the CU only. So when CPU is doing any kind of work, so we can say that internally CU is working on it. And what does the memory unit do? The memory unit, for example, we can say that RAM. For example, so in many of these things, why does we need one memory unit? So many of the situation, what the user wants, user don't want to see the output, right? Many of the things, let's say we had some instruction here, 5+2, this kind of thing. Okay. So in this case, user wants that result in here in output unit or on the screen, right? But many of the cases, they don't want to see the output. Simply, they want to perform calculation and they want to store the data in the memory. So this time the memory comes into place such that they can store the output in the memory unit itself, and they can use it later. Okay, so this is the basic structure of the computer. Now, if we talk about the memory, so we have various memories in our in the computer architecture. So if we talk about the memory, we have, let me explain this with a diagram. This is a pyramid, right? So this is a pyramid, and let me write first and then I'll explain you one by one. So this is a pyramid, and the bottommost layer is the secondary memory. Okay. After that, we have a primary section, primary memory. And after that, we have a cache memory. And at last, we have CPU registers. Okay, so these are these four storage memory units. All these components are basically used to store data in a way. Okay, so yeah, secondary memory, primary memory, cache memory, and CPU registers. So see, you can notice the structure of this pyramid, right? You can see that the width is more in the bottommost, and when it is going up, the width is becoming less. So what is the reason behind that? So see, if we talk about the secondary memory, okay, secondary memory, the bottommost part of the memory. So here we have the components like CD, DVDs, this kind of thing, right? Pen drive, hard disk. Okay, So these are the things which are also called as external memory. We also call these memories as a external memory. Okay, so here the size is very large. Size is the largest. Okay, size is the largest. Yeah, size is largest. And speed is the lowest. Speed is lowest. And if we talk about the primary memory, right? So it is also called the it is also called the main memory, and the RAM and ROM. This all kind of things are there in the primary memory. So size is less than the secondary memory, but speed is more than the secondary memory. If we talk about the cache memory, so now basically a computer uses cache memory in order to work with CPUs more faster, right? So I'll explain these things one by one. So yeah, this cache memory, the speed is more than RAM and ROM, and the size is less than the primary memory and the secondary memory. Okay, this is the cache and the CPU registers. So apart from the CU and LU, okay, so we can see that in the CPU we have two parts, right? CU and LU. So apart from the CU and ALU, registers are also important part of the CPU. Okay, so we have CPU registers within the CPU itself, and they are very small components. Okay, so the CPU registers are very small as compared to the cache and primary and secondary. So they are very small storage components with all the so they can use to store. They are used to store the data, and it is also called the smallest memory among all. Okay, so these are the basic description about the memory. So the speed is the highest at the register at the highest speed, and if we take this, so secondary memory has a highest capacity. Okay, so this is the basic structure. From here we can see that memory hierarchy, we can figure out the memory hierarchy basically. So yeah, if I talk about them in more details, let me
One question, like where does
yeah.
SSD and HDD come here?
What
Where-
can you?
Where do SSD and HDD come in this hierarchy? Like where does it come?
Okay, so here in the secondary memory itself.
So like SSD and HDD then have the different like SSD is better than HDD. Like in secondary memory, then we have more hierarchy. Like
Yeah. Okay, I'll explain you that what is the difference between SSD and hard disk and why we are preferring SSD nowadays. So yeah, so the SSD is placed in the secondary memory itself. Okay, but nowadays it is it is rapidly used. But why? The reason before that, okay, I'll tell you in some time. Let me clear the screen first. Okay, so see. So if we talk about first the primary memory, okay, first will be the primary memory. So the major primary memory is the RAM and the ROM. Okay, RAM and the ROM. So see, RAM is further divided into two parts. That is SRAM and DRAM. Okay, and RAM, there is not much of the use of ROM as far as this week is concerned, but for your understanding, ROM is further divided into PROM, EPROM, and then triple EPROM. So these are the three subdivisions of ROM itself. So if we talk about the RAM, okay, so RAM is volatile memory. Okay, volatile means as soon as you turn off your computer, the data inside the RAM will be erased, right? Whereas ROM is, this is a volatile and this is an non-volatile. This is one difference. Okay, this is volatile. This is a temporary memory. We can say that it is also a temporary memory. So we under within the RAM, we have two subdivision called as SRAM and DRAM. SRAM and DRAM. Now, so let me give you one example. Let's say we have open our smartphones and when we are playing multiple games on that, okay, or open multiple apps at the same time, multiple apps, okay, multiple apps we are opening in our smartphone at the same time. What will happen after some time? So you'll notice that our phone is getting slow, or it's just hanged for a while. So what's the reason behind that? So as we had discussed in the previous figure, that RAM has very not very large capacity, right? As comparison to hard disk and SSD, this kind of thing, they have somewhere a smaller capacity. So what the reason behind that, why our phones were hanging and that kind of thing were happening? So, because our RAM capacity will get has to be filled, okay? So the size of RAM is smaller as compared to all the disk. So this will be filled up easily. So this is the thing. First thing, okay. Second thing, SRAM, if we talk about SRAM and DRAM, so SRAM doesn't require any power to be continuously supplying to them, to the chips of SRAM. So whereas if we talk about DRAM, you need to compulsory view the power supply. Okay, so it need a power it does not need a power supply, and it will need a power supply if we talk about the DRAM. So in the case of DRAM, if we don't give the power supply, the content of this DRAM will get erased. For example, let us I had opened 10 games and 10 game apps, and those I will be running in the RAM. So as soon as I'll switch off my mobile phone, so you can see that all contents in the RAM will get erased, right? Automatically it will be erased, all the data regarding that games that we had opened. So it is the DRAM, right? It is basically the DRAM is functioning. So in order to store the content like that, you need to this type of things, you have to continuously give the power supply to the circuits or the chips of the DRAM, right? So whereas SRAM, does not need any kind of power supply in that. Okay. So second thing is that SRAM doesn't needs power supply, and DRAM needs continuous power supply. Third thing is the usage. The SRAM is used as a cache memory. So what is a cache memory? I'll explain you. So yeah, SRAM is used as a cache memory inside the computer, whereas the DRAM is used as a main memory. This is a used as a main memory, and this is a cache used as a cache memory. So the reason the SRAM is used as a cache memory because of its speed, right? We had discussed that SRAM doesn't require any power to be continuously supplied, right? So SRAM has more speed than the DRAM. So SRAM, that's why SRAM is used as a cache memory, and DRAM is not. So SRAM is the fastest among all of the memory that we had discussed so far, and after that we can say that DRAM is faster as compared to all the memory that we had discussed. Okay, so in terms of cost also, SRAM is costlier. Of course, it has a highest speed, largest speed, so that's why it is costlier as compared to the DRAM. Okay, So this is all about the what is the primary memory, right? If we talk about ROM, so see, first thing is it it stores those data types. It stores those data types that are most often used, okay, only for the reading purpose, and we cannot kind of modify the data on the ROM. We can also only read it, as we can see from the name itself, read only memory. So we can not modify, we cannot do modifications on this kind of memory for C. Yeah, so this is all about ROM. We are not going into deep into the ROM and its EROM from these things. So this is all about the primary memory. So yeah, second was the, yeah, this was the second from the bottom, right? Third was the cache memory. So what is a cache memory? If I tell you what is a cache memory, as we have discussed the cache memory here, it is SRAM is used as a cache memory, and DRAM is called the main memory. Why it is so? So let me explain what is cache memory. So whenever we install any software, what does software means? Set of instruction, right? So yeah, whenever we install any software on our on our computer, what does that mean? Okay, so our CPU won't execute the entire software at a time. Okay, so where that first of all, where that software will be installed? On the hard disk, right? On the hard disk it will be installed. So now if the instruction to be performed by the CPU, so what is that? What will be the flow, right? So our components, our software that we are installed is in the hard disk, okay, hard disk, and the CPU is the place where all this instruction will get processed, right? So how does this happen? So our CPU won't execute entire software at a time. Okay, our CPU will execute instruction by instruction. Once first instruction is executed, then second instruction will be executed after that. Then third, then fourth, and this whole cycle is called like instruction cycle. So what is the role of cache memory in the execution of those programs, right? Where those programs are situated on the hard disk itself. So whenever you install any software or any program, they are always stored in the hard disk. Here is our hard disk. So let's say this is our hard disk. So yeah, so when all the instruction and all things are stored on the hard disk, which is very large in capacity, right? As we are discussed in the previous slide, very large capacity. So yeah, so let's say we have installed one software. The entire software is loaded in the hard disk now, and it is the place where our program resides. Now here is our CPU. Here it is our CPU who needs to execute the program. Okay, the program is in the hard disk, and the CPU wants to execute the program that is situated on the hard disk itself. So what do our CPU do in this case? So the CPU means CPU will basically execute all the instruction. So how did this happen? So our CPU execute those instructions that are available on the hard disk. So directly, my question is directly, can our CPU will take those instructions from the hard disk? Can someone say this?
No.
Yeah.
It will be first loaded into RAM.
Yeah. So yeah, correct. So directly, the CPU will not take the instruction from the hard disk itself. It is not possible, right? It can't directly go to the hard disk and can request for the instruction. So what will the CPU do in order to execute this instruction? In between our CPU and hard disk, there is one important memory known as the main memory, which is also called the RAM or the main memory. Okay, so the size of hard disk is very large. We know that, right? Larger than the RAM also. So let's say we have some 100 GB of software that is installed on the hard disk, right? Then let's assume the size of RAM is 16 GB. Yeah, 16 GB. So let's say our program size is 100 GB and RAM size is 16 GB. So it won't take, the RAM won't take that 100 GB at once, right? Because this has only capacity of 16 GB only. So what does this do? It the CPU, what will the CPU will do? The CPU will only take those amount of memory which the RAM can give it to CPU, right? So 16 GB at once. So let's say a necessary part is so let's say only the 16 GB is gone to the RAM, and the only necessary part is going to the CPU. Okay, so initially the data will be stored in the hard disk. From the hard disk, it will go to the RAM, and only the necessary part, only the part which RAM can store is had to be sent to the CPU. Okay, from the RAM. So CPU will execute those instructions, right? The CPU will execute that 16 GB of instruction that the RAM has transferred. So if CPU wants to execute the previous instruction, number one, okay, the first instruction, let's say this instruction cycle is a continuous working, right? So this thing is continuously working. Okay, this is a instruction cycle, this kind of thing is happening. So let's say if CPU wants to execute the instruction number 1, let's say it is executing the instruction number 5 or 6. So what happen if it wants to execute the instruction number 1 once again, second time? The CPU, instead going to the hard disk, it directly will take that data from RAM. This is possible, right? Because all the instruction are coming to the RAM first and then going to the CPU. So if once again CPU wants to execute any kind of instruction, so it will go to the RAM and does not have to go to the HD hard disk, right? So because the instruction is already available on the RAM itself, so it will go to the RAM. So for example, the application that has opened on the mobile phone, right? So if you minimize all the applications, so there is a tab, right, where all the minimized apps are there. All the minimized apps are there in the standby mode. Again, if you go and open that application, if you, let's say, if you open an application at the very first time, it will take a longer time to open that application, right? It is obvious. But if you minimize that app, and if you open that app once again, which is in the standby mode or in the minimized mode, it will not take much more time. Okay, it will take less time as compared to the previous time. So why it is happening? Because it is had stored in the RAM only, right? So whether that application is in the standby mode, it will open fast as compared to the previous time. Yeah, so all this process and sequence is okay, all right, but the problem is this sequence of speed, right? What does I mean from this particular line is that, see, speed of main memory or the RAM is fast as the hard disk, and the speed of CPU is more faster than the RAM. Okay, so this is very fast, very fast. This is somewhere faster as compared to the HD, but not as fast as CPU. Okay, so which means it will be some synchronization needed in between, right? The problem between the CPU and the RAM, there is a synchronization problem, because the speed of CPU is very fast whereas the speed of main memory is fast, but not so fast as compared to the CPU. So what it is not been, we are not able to match the speed of CPU and RAM here. So because of that, in between the CPU and the memory, CPU and the RAM, we are one small amount of fast memory, very small amount of fast memory, which is known as the cache memory. Okay, this is known as the cache memory. So first, the instruction will be bought. So this is the memory. So first, the instruction will be bought into the hard disk. After that, it will go to the RAM. From RAM, it will go to the cache memory. Okay, and from the cache memory itself, the CPU will take the instruction. CPU will take the instruction, and lastly, it will execute that instruction. Okay. So what if the CPU wants to execute some instruction second time? So will it have to go to the RAM? No. So instead of going to the RAM, it will go to the cache memory itself and can fetch those data. So cache memory is nothing but a small amount of fast memory, which is mainly used to increase what the transfer speed of CPU and the main memory. It is just a small temporary memory which is used to increase the transfer speed between the CPU and the main memory. Okay, so this is all about the cache memory. So this was the third thing. The cache is the third thing. So let me yeah, till now, is there any confusion?
If the capacity of RAM was 100 GB, then it would have downloaded the software, like it would have taken the software in one instance only instead of taking it instruction by instruction, right?
Yeah, if the software is whole as compared, if I talk about the software, it is 100 GB, right, in total. So it will execute instruction by instruction, and then can the CPU then execute those instruction. Okay, so RAM is small, right? RAM is very small as compared to HD.
But if RAM's capacity is 100 GB itself, so it will take the software at once only, like instead of taking it step by step, right?
So no, see, in the program itself, we have many functionality, right? So CPU don't have to process and execute all of the functionality itself at one time. It needs, let's say we have a software and we just want to, we just clicked on one thing and we just have to fetch one amount of data only. So we don't have to go to the other section and what we have to fetch only some amount of data. So the CPU only wants those amount of data which has to be fetched. Okay, so yeah, we can also execute all the instruction at once, but it is not needed, right? CPU will only process those instruction which is had to be processed or had to be fetched by the end user. So yeah, RAM is very small. We can't imagine RAM as 100 GB as of now. So yeah. Okay. So let me clear the screen. Any more questions?
Ma'am, you said that SRAM is uses cache memory. So like we use SRAM in this cache memory, like in the third option you said. Like I have confusion regarding this SRAM and cache. Like, is there any difference, or like we use these?
No. This cache is SRAM itself. Okay. So here we are using DRAM, right? DRAM is used as a main memory, right? I had told here in the point number 3.
But then why does SRAM come under primary? Should come on the cache memory SRAM.
Yeah, so in the primary memory itself we have RAM. Okay, and after that RAM is subdivided into SRAM and DRAM, whereas this here the main memory is used. Here the main memory is used in between the HD and the CPU. But here, if we talk about the cache memory, here we are using we are using the SRAM. They are both the types of RAM only, right? This DRAM and SRAM, both are the types of RAM only. So I don't get your questions clearly. So can you elaborate what you are asking?
Like my question was that SRAM comes under primary memory.
Yeah.
We have another section called cache memory. Why don't we write S memory in cache memory section? Like, why is it in primary memory section? Because SRAM is cache only.
Hello.
Yes, ma'am. Because SRAM is cache only, so it should come in third one, like not in primary memory.
So see, in the previous where I am explaining you the hierarchy. So cache memory is not any kind of memory. In the computer itself, we are just using two kind of memory basically: primary memory and secondary memory. Cache memory is nothing but the SRAM only. It is not any further subdivisions of primary memory or secondary memory. It is just the type of SRAM only. Okay, SRAM is used as a cache memory. But in the hierarchy section that I have explained, I am explaining the speed and capacity, just in the reference to speed and capacity. If we talk about cache, if we talk about RAM and ROM, if we talk about STD and HDD, all the things, I'm talking about the hierarchy and how much data it can store and how much the speed is still. Okay, so cache is nothing a individual memory. It is just the RAM only. Okay, RAM, or we can say that the SRAM only. Okay, this is in the SRAM only. This is not any individual memory, or basically we have two memory in the secondary and primary. This is cache memory is just in the SRAM itself. Okay, we are used here only in between the CPU and the HD. Both the RAM is used. The RAM, one part of SRAM and one part of DRAM is used. Okay, cache is in the RAM itself. What you are saying is right in some ways. So it is not an individual thing. It's just a reside in the SRAM, or we can also say it SRAM as a cache memory. Are you getting my points? I'm making you confused. I don't know, but as far as I could understand your question, you are telling that cache. What you are telling. Can you repeat me once again? Are you clear with your question?
Little bit, like if it's cache memory, it's not a memory. It's just a name given.
Yeah, it's just a name given. It's nothing like a memory components of a computer. It's just a name given, and to which component this name is given, that is the SRAM. Okay, SRAM is nothing but the RAM itself.
So in hierarchy, if I want to point like where does SRAM exist, then I would say it's in cache memory, not in primary memory. Is that right?
So see, here I explained, right? See, SRAM is more in speed, in speed as compared to comparison to DRAM, right? Okay, I have explained in the previous slides, right, that SRAM doesn't require power supply, this kind of thing, and DRAM required power supply. So if we talk about the hierarchy within the RAM, so SRAM is more speed efficient than DRAM. So that's why if we are talking about the memory hierarchy, so cache memory or the SRAM is more in speed than the DRAM. So that's why we are talking about cache memory individually there. So yeah. So if I talk about caching, okay, you know about caching, right?
Yes, ma'am.
Yeah. So there we use cache memory. There we use that RAM, which I'm talking about. That the memory used in between the two, between the servers, that is nothing but the cache memory. The caching uses the cache memory for caching functionality. So yeah, this thing.
And registers are also like an abstract concept. Like
Yeah, registers is very vast concept, but if you talk about the CPU registers, okay, if you talk about the CPU registers, so that is also a memory component which is used to store the data. It is in the CPU itself. So it is it has the highest speed because it is in the CPU itself. CPU does not have to go to the hard disk or go to the RAM to fetch the data. It's just have to go to the register which is within the CPU, and they can execute the instruction. Okay. I'll tell you about CPU registers and that hard disk and STD in some time after that. So I think that will be more clear after if I go to that point.
okay, ma'am.
Yeah. Okay, so let me. So if we talk about CPU register, right? CPU registers. So we'll not go very much deep into the register. Register is a very vast concept. Okay. So CPU register is a small high speed memory, very small and very high speed. Very high speed memory inside the CPU. Okay, it is inside the CPU. So why it is used? It is used to quickly store the data, and CPU can accept it and transfer it, and the instruction that is being very immediately used by the CPU. So that's why we are calling. We are in the hierarchy table. We saw that the CPU register have highest speed because it is in CPU itself, and CPU has the highest speed among all. So yeah, so register used. This register used in the CPU are often called as the processor register because CPU is nothing but the processor. That's why this register is also called as the processor register. So the CPU in the registers in the CPU, the size of the registers in the CPU determines how many information it can store, how many instruction or how many data can it store within the CPU itself. The size of a register is in especially stores in the bytes, and each byte will contain one character of data. So a register is very small, right? It just have, I think, 4 to 8 bytes maximum. So yeah, the performance of this register, the register which is inside the CPU, it basically responsible for the performance of the CPU. Okay, basically responsible for the performance of CPU. If the size of register is more, the CPU performance will also more. CPU will be able to fetch more instruction at the time, and it will execute the instruction more fastly. So there are many types of register. We are not going into much detail. For example, we have a program counter, we have a MAR register. So we are not going into very much details into the CPU register. Just the thing is that it is very small in size, it is very high speed, and the instructions as far as the activity questions of this weeks are concerned, I'm telling you that these are the points which will be helpful to in solving those questions. So yeah, they are high speed, they are small in numbers, and they are temporary memory that are within the CPU such that CPU can fetch those instructions very quickly. So this is the fourth, right? So if I come on the first number, secondary memory. So computer, we saw that we have two main types of memory, right? we have primary memories and secondary memories. These are the main memory that we are talking about. So now primary memory, we had discussed that we have RAM and we have ROM, right? So now every computer needs a place to store their data, whether the data is uh, photos or any kind of videos, documents, audio, these things in, and this they want to store this kind of information internally on a storage device which is non-volatile and which is also very permanent. Okay, a permanent and non-volatile means if the light will go off, it will light will turn off, it will retain the data and it will not erase the data, right? If we talk about primary memory, if we're talking about RAM, these are not these are volatile, right? They are volatile. If we turn off the light, turn off the electricity, and we are breaking the chain of power supply, so it will lost all of the data. But in the case of secondary memory, they are the memories that are non-volatile, and it is a permanent memory, right? So there is different types of internal storage devices that a computer use, and some of them are hard drive, state drive, solid state drive, SSD, HDDs, and we are also called as hybrid drives. So this is also one of them. So see, if I talk about hard drive, so these are nothing but the hard disk drive. Okay, so hard drive is a sealed case that contains magnetic disk. If it go into the configuration of hard disk drive, so it contains this kind of magnetic disk. Okay, and these are the places where the actual data is stored. Okay, so these are the places where data is stored, and these disks are rotating. Okay, these disks are rotating with a very high speed, and as the arm, or we can say that within the moving disk, we have a read head and we have a write head. Okay, these are the terms you can read it from the website, web only, web also. So I'm not going into very much detail in the configuration of the hard disk, but if we talk about the hard disk, the magnetic disk inside the hard disk have some kind of pointers. Read and write heads are read and write heads are present on the magnetic disk, rotating magnetic disk. So so this rotating disk is nothing but we are measuring the speed of this rotating disk in RPM. As we can see in one of the practice session, that magnetic disk is moving at the speed of this RPM. So RPM is nothing but the unit to measure the rotation of that magnetic disk only. So this typically hard drive that we use today in the desktop computers or this kind of computers, they basically have operates at 7200 RPM. This is the unified speed range, which is for the computers. Okay, the cheaper desktop have hard disk of 5400 RPM. And if we talk about a typical laptop, it is much lower, right? So this is the unit that we can measure the speed of the rotating magnetic disk inside the hard disk. So today we this is all about the hard disk. So if we talk about SSD, this is nothing but the another type of storage device, solid state drives. So now in these drives, there are no moving part, right? Here the magnetic disk are moving continuously, as we can see this from the here. But in the SSD, solid state drive, we have no moving parts. So instead of that magnetic disk, these drives use flash memory. Okay, so instead of that moving disk, the SSD used flash memory chips. Okay, flash memory chips they are using to store the data. So the data execution and the data transfer speed is very fast as compared to the HDD, because it has no moving parts, right? So and in addition, if we see, so if there are no moving parts, they are very quiet also. Okay, there are no sound. If we talk about the sound that are releasing in the HDD, there is no sound because there are no moving parts, and more energy efficient also, this SSD. So yeah, we are not going into much detail into SSD also. So all these things I have explained, they are all the memory components, which is somewhere here and there are used to store data in a case. Okay, so if we talk about first we had talk about the primary memory, we had talk about RAM and ROM, and the SRAM and DRAM, right? After that we talked about that cache memory, we talked about secondary memory, we talked about CPU registers. So all of these things are somewhere used to store data. Store data and talk about the hierarchy. So that was the hierarchy table that I had drawn at the first. So you can saw from that also that for very CPU registers is very fast as compared to all of those those components, storage components. So yeah, this is all about the memory hierarchy. So any questions? Till now? Let me stop sharing first. Okay, if there is not any question, I'll stop sharing, but if any question, please ask. Okay, so everything is clear. Okay, I can't see. Is anything on the chat? Okay, there is nothing on the chat also. So if everything is fine and nothing to ask, then we can wind off. But if anyone wants to ask something, they can ask by unmuting yourself, or you can also post it on chat. Devi ma'am, are you there?
Yes, Sonal, I'm here.
Yeah, so I think we can wind off if
Yes, we can close the session.
Yeah, okay. So if you have any queries that you had not asked yet, or you're unable to speak.
See, I want to ask one student, that Saurabh Raj, whether his issue has been sorted out.
Yes, ma'am. Yes, ma'am.
That calendar issue, right?
Yes.
Yes, ma'am. Actually,
Yes.
I was making mistake of not selecting my official email ID
Okay.
to
Okay.
associate that calendar.
Okay.
It has been now sorted out. Thank you, ma'am.
Okay, thank you. Then there is no issues, mean we can wind up sooner.
Yeah. So yeah, we can see that the time is also passing through. So yeah, you can also post it on Discourse as well.
Okay. Thank you all.
Yeah, thank you.
Thank you, ma'am.
Thank you, ma'am.